We are continuing the review with 21. 21 says, which statement can you use to conclude that quadrilateral X, Y, Z, W is a parallelogram? Well, I'm looking and I'm seeing all these segments in the answers here. So let's look at them and see which, we'll just go through them, see which ones would work. A says YN, that is one of the segments of the diagonal, equals NX. Well, those wouldn't be equal anyway. Those are not segments of the same diagonal. So I can cross that one out. A doesn't work. Okay. Look at a B. B says that XW equals YZ. Also would not be true. Those are not opposite sides. Can't be B. Looking at C, it says that XW equals YZ. Well, that's true. Those are opposite sides. I'm going to go ahead and mark those on my figure. And it says that XY equals WZ. That is the other pair of opposite sides. So C then is our correct answer. If you want to look at D, the second part of D says that XY equals YZ, and those are not opposites. It's definitely C. Looking at 22, based on the information given, can you determine that the quadrilateral must be a parallelogram? There is some given information here, so let's mark it. This given information says that XN equals NZ. So I'm going to put a single slash through XN and through NZ, which is showing me a diagonal bisected. And the next piece of information says NY is congruent to NW, which is the other diagonal bisected. So we can conclude that this is a parallelogram. I'm going to say yes, because the diagonals bisect each other. Diagonals bisect each other. Okay. For 23, it says to classify this figure in as many ways as you can. There are some weird little symbols in the corners, so we added a note here that says that all four angles are right angles. So we have all four angles right angles, and we have all four sides marked congruent. So what is this figure? The figure is a square. All four answers have square in them, but we want to classify it in as many ways as possible because it is. Square is a special rectangle, a special quadrilateral, a special parallelogram, and a special rhombus. So you guys are correct. It is A. On 24, it says in the rhombus, the measure of angle 1 is 15x, and I'm going to put these next to the angles inside the figure. Angle 1 equals 15x. Angle 2 equals x plus y. Okay. And angle 3 is 30z. Okay. Now this is a rhombus. One of the most basic things that we know about a rhombus is that the diagonals are perpendicular. Diagonals, make a note, diagonals of a rhombus are perpendicular. Okay? What that means is each one of those is also going to equal 90 degrees. So we can set up several equations. 30z equals 90. Because of that, dividing by 30, we know that z equals 30. I'm sorry, 3, not 30. Okay. We know that 15x equals 90. So dividing both sides by 15 tells us that x equals what? 6. Okay. And we know that x plus y equals 90. And we now know the value of x is 6, so we can say 6 plus y equals 90, and then just subtract 6 from both sides to get that y equals 84. Okay. Got our 3 variables there. Okay. On 25, it says in the rhombus, the measure of angle 1 is 140. What are the measures of angles 2 and 3? Well, in a rhombus, opposite angles are congruent. So what angle is also 140? 2, good. And we know that the diagonals bisect the angles. And since all sides are congruent, we're actually looking at an isosceles triangle down here at the bottom, where 140 is the vertex angle. So 140 from 180 gives us 40 for the other two angles, which we'll then have to divide by 2. So here we are using the isosceles triangle theorem and the triangle sum theorem to find out that angle 3 is 20. Okay. On 26, it says that DEFG is a rectangle with diagonals DF and EG. It gives you a hint to draw a diagram. So I'm going to draw a rectangle as best I can with this pad. Okay. Labeling it DEFG so that DF is a diagonal and EG is a diagonal. Okay. All right, and it tells me that DF is 5x minus 3 and EG is x plus 5. Find the value of x and the length of each diagonal. So we're working under the concept here that the diagonals of a rectangle are congruent. Diagonals of rectangle are congruent. What that means is that 5x minus 3 equals x plus 5. Okay. So I'm going to subtract x from both sides. Which gives me 4x minus 3 equals 5. So then I'm going to add 3 to both sides. Sorry, I'm running out of room here. Okay. So at this point, I have 4x equals 8, which means that x equals what? Good. X equals 2, and we need to find the length of each diagonal. Well, they're equal to each other, so we can simply substitute that 2 in for x plus 5. So x plus 5, or 2 plus 5, gives us that each diagonal is 7. Okay. The value of x is 2. And the value of each diagonal is 7. Okay? All right, 27 in quadrilateral ABCD says the measure of angle ACD. ACD is 2x plus 4. I'm going to type that into the angle here. 2x plus 4 for angle ACD. And the measure of angle ACB is 5x minus 8. 5x minus 8. Okay, wants to know for what value of x is it a rhombus. In a rhombus, the diagonals bisect the angles. Let's make a note of that. Diagonals bisect the angles. Because of that, we know that those two equations are going to be equal to each other. So 2x plus 4 equals 5x minus 8. So I'm going to subtract 2x from both sides. So on the left side leaves me with 4. On the right side leaves me 3x minus 8. I'm going to add 8 to both sides, which gives me 12 equals 3x. My last step then to divide both sides by 3 gives me that x equals 4. All right. 28 in quadrilateral ABCD. AE is x plus 6. Let's put that on AE. X plus 6. And it tells me that BE is 3x minus 18. For what value of x is it a rectangle? Well, in a rectangle, the diagonals are congruent and they bisect each other. Diagonals are congruent and bisect each other. Okay, so that means that all 4 of the pieces of the diagonals are going to be equal to each other. So we can simply set x plus 6 equal to 3x minus 18 and solve. Subtract x from both sides. To the left side leaves me with 6. The right side leaves me with 2x minus 18. Next step would be to add 18 to both sides, which gives me 24 equals 2x. And dividing both sides by 2 gives me that x equals 12. All right. 29. Say again? Oh, yeah. Do you need to go through it again, or you just need a second? Okay. Just looking at 29. 29 is what kind of figure? Trapezoid. We see a pair of parallel sides. Okay. In any trapezoid, same side interior angles are supplementary. I'm going to make a note of that. Making a note on 29 that same side interior angles are supplementary. I'm going to use that concept for each one of these. Okay, so I have got two sets of same side interior angles here. A and 65 are same side interior, and B and 109 are same side interior. Oops. Okay. So I can set up equations that say 65 plus A equals 180, and another equation that says 109 plus B equals 180, and solve for both. So then I subtract 65 from 180. I get that A equals 115. Good. And when I subtract 109 from both sides, or 109 from 180, I get that B equals 71. Okay. So in 29, I got A is 115. And I got that B is 71. I may have just lost my tablet. I don't know what I did. Okay. 30. Angle J and angle M are base angles of an isosceles trapezoid. Well, by the concepts of an isosceles trapezoid, we know that base angles are congruent. Okay? So if J is 18 plus 8 and M is 11x plus 5, we want to find the measure of angle J. But first, we need to set those equations equal to each other. Okay? So 18x plus 8 equals 11x plus 15. I'm going to subtract 11x from both sides. Which gives me 7x plus 8 equals 15. And subtracting 8 from both sides. Which gives me 7x equals 7. Alright, so x equals 1. If x equals 1, then I can substitute that back into either one of these equations because they're congruent. I could say 11 times 1 plus 15 gives me what, 26? So the measure of angle J is 26. 26 degrees. Okay. All right. 31 and 32. They give you the same figure, same concepts here. Here we have mid-segments or medians of trapezoids. In some resources, mid-segments are referred to as medians. You may want to remind yourself of that. Okay. and the midsegment is half the measure of the sum of the bases. So let's put the information on the pieces. For 31, that top base is 72. That bottom base is 104. And we are looking for LM. So we know that 2 times LM equals 72 plus 104. 72 plus 104 is 176. So we just need to divide 176 by 2, which gives us what? 82? 88? Thank you. Okay. Yep, 88. So we know that LM on 31 equals 88. I'm really sad that I lost my tablet. I'm not good at writing with this pad. All right, so for 32, we're doing the same concept, but we're doing it with expressions. So it says that AB is x plus 8. It says that LM is 4x plus 3, and it says that DC is 243. So we're working under the concept that 2 times the median, or 2 times the quantity 4x plus 3, equals the sum of the bases, or x plus 8 plus 243. We're going to distribute and simplify. Okay, remember when you distribute, you have to distribute to both terms inside the parentheses. This is the most common error when distributing. Okay, so 2 times 4x is 8x, and 2 times 3 is 6. So after you distribute, you've got 8x plus 6 equals x plus, and I'm combining those like terms, 243 plus 8 is 251. Now it's just a multi-step equation. I'm going to subtract x from both sides. This gives me 7x plus 6 equals 251. I'm going to subtract 6 from both sides, which gives me 7x on the left equals 245. And then I'm dividing both sides by 7, which gives me x equals 37? 35. Wow. Okay. All right, x is 35. Good so far? Last page? Yay, okay. Last page. On 33, it says find the measure of angle 1 and angle 3 in the kite. Interesting. What's angle 2? That's 90 degrees. We know that the diagonals are perpendicular. Okay. We also know that the long diagonal bisects the angles that it hits. So what's angle 1? That's 17. Good. Okay. Angle 3 we can find using the triangle sum theorem. Or we can notice that since this is a right triangle, the two acute angles must add up to 90. So we can simply say 90 minus 17. What is 90 minus 17? That is correct. Good job. Okay. 34, our other kite problem. This says find the values of the variables and the lengths of the sides of this kite. Okay, this particular problem has tripped geometry students up for years because the first thing you see is y minus 3 equals x plus 2. You have two variables there. But look down. Here you have, at the bottom, the sides with the two slashes, you have two expressions with x's in them. So start with that. 2x plus 2 equals x plus 11. We're going to solve for x here. Subtracting x from both sides gives me x plus 2 on the left. On the right side I have 11. I'm going to subtract 2 from both sides. This gives me x equals, good, 9. So now that I know that x equals 9, I can plug that in for the upper expression. X plus 2 equals 9 plus 2, which equals 11. So now I know that y minus 3 equals 11. So all I need to do is add 3 to both sides. Eleven plus 3 is 14. Okay. It says find the values of the variables and the lengths of the sides of this kite. Well, we know those two upper pieces are 14, right? That one's 14, that one's 14. And if x is 9, 9 plus 11 will give us this lower piece, which equals, I'm sorry, the upper piece is 11. No, you're correct. Thank you. Y is 14. The upper piece is 11. Yes, thank you. Okay. Now, if x is 9, 9 plus 11 is 20, so these bottom pieces are 20. Thank you for catching that. Okay. Oops. Okay, so we have a lot of answers here. X is 9, y is 14, and then we have sides of 11 and 20. Okay. Our last 4. And I did give you graphs on that last page so that you guys can graph these. If y'all need to come grab rulers, you're welcome to. Okay. People watching this video, pause it. Go get graph paper and ruler. On 35.